Hello, welcome back to my bench. If it's your first time here, hi, my name's Dave. I fix electronic equipment with a specialty in broadcast equipment of all kinds, basically, but pretty much the older stuff. If you're interested in that kind of thing, don't forget to subscribe and ring that little bell so you get notified when I put something out. And if you're returning, welcome back. I do have a Patreon channel if you would like to support what I do. I'd much appreciate it. It's Patreon/AERV blog. And all of my videos are available up on Odyssey if you want to go there to see them. So, let's get on with this. Today we have a Akai S612. This is it's around an 84, 85 machine, someplace around there, and it is a Midi sampler. Interesting machine. It would take in Midi from the back here, and you could record samples. You could play them back. You could splice them. You could rotate. Repeat them over and over again. You just record a bunch of them and get them to make that MIDI music that was such a big deal back in the 80s, and actually still is. You just don't know it. These machines were just full of ICs, as you can tell. A lot of 7400s, series stuff, memory for storing your slices or your samples, and all through hole, of course. They had one big drawback, and that was that when you turned it off, you lost everything, unless you had the thing that plugged in back here, which was a floppy disk of sorts. And now I understand that they have a thing that you can plug back in here that is a floppy disk emulator that goes onto little SD cards. That's kind of cool, That's a lot of that's happening now with these old machines, like old Commodores and things. They have hard drive or floppy drive replacements that you can plug in and use SDHC cards, and that was interesting. Gotta love that. Anyhow, but this one here, the guy gave me to work on, and he says it actually does work. He just wants to do for some preventive maintenance. These things were pretty much rock solid, with the exception of this little piece over here. This is the power supply. The power supply is linear. It's not switching. And it is a heat producer, like most of these older power supplies were. And what he wants to do is preventive maintenance on this, because these things would start losing regulation. What happened with them was most of your power coming through this power supply board was regulated through a couple of transistors right down here, and those transistors started to leak. So what we have to do is find out what they are now, and possibly get some if we need to. There are things that you can buy, newer ones that are quite a bit more rugged. Plus, we've got to find out if the caps are any good. But let's find out right now if this thing is indeed starting to go, because what you would see when they started to go is the voltages would start to rise, because these transistors would start to leak, plus the capacitors would go bad and bulge. I don't see any bulging capacitors on here, but we're going to recap this thing anyway. But we'll test them and find out. And we're going to check the plus and minus 15 volt supplies here too. So basically what it did, it would come in with the power from the transformer in here, rectifiers on board right there. That's the you can't see it. It's yeah, move you over just a shade. Yeah, right there's the bridge rectifier, and all of your voltages are supplied on this board. So that was its big problem. So we're going to check that out. So let's get on with it. I've got the my new little scope meter over here set up for DC voltage, and I know the thing works because he told me it was fine. So we're just going to plug it in, turn it on. It's on now, and we're going to check and see what voltages we have. If we go to the manual, well, that's not it. There we go. If we go to the manual, we can see that all of the voltages here are available on this pinout right here. We got a plus and minus 5 and a plus and minus 15, and the where we could test those is right here. So let's go down to here. What do we got? We got a minus 15. Okay. Let's take you back up to right here. Okay. All right. So we got minus 15.3. That's okay, but that's, that's good enough, I guess. This one we got a plus 15. We're not showing anything as far as ripple here. So it looks like probably our capacitors are okay, but it doesn't matter. We'll change them. And we got minus 5.3. That's a little high. And plus 5.4. That is still a little high. We really don't want those voltages to be that high. We need to get those back down. So first thing out of the box here is to take this guy out. So we can turn that off for now. It's running on batteries. I got the battery pack for it. And we'll turn you off and unplug you. Get the old screwdriver here, and let's see what holds this thing in. Well, one thing I want to do, just to make life easier on myself in future, when I put this thing back together again, is I want to take a picture of it. Okay. Pull off these little clips. Some of them are locked on, some of them are not. So you got to be careful, because this plastic of this age with these clips gets really, really brittle. So there's those guys. Little clip on the back of the AC input. Yeah. Alright, there's that one. They put them real close together, I'll tell you, that's for sure. There's that one. You don't see these types of clips much anymore. There we go. There's those three. And that one there. Looks like everybody. All right. There's one screw there. And one right back here. I think that's it. Never had one of these apart. Matter of fact, I've only seen two of them. Well, there's our board. Huh? Little jumper wire. Looks pretty good. I can't tell. I can't tell if this has been worked on before or not. I don't think so. It's just some leftover flux. But it looks pretty clean. It's got a 2SB 1015 there. And these guys are 2SB 891 and a 2SD 1189 and 2SC 3243 plus a couple of little guys down here. I don't know what those are. 3330s. Oh, and 7915, 7815, and some of this awful glue. And it's starting to turn real browny brown there, so we'll have to clean that off the board too. And there's some touching right there. All right, well, let's get this guy off the bench. All right, well, looking okay. First of all, let's find out. Put that guy on ohms. Let's find out if this glue is leaking. Or this glue they put on here. Find out if it's conductive yet. It probably isn't, but I wouldn't sit. But I wouldn't doubt it if it was. No, it's not. Good. And it's still just a little bit on the gooey side. We're going to scrape all that off anyhow. Let's see. Well, I guess probably one of the better things we can do here. Let's check the caps. I just want to check them. I'm going to change them, but I just want to check them and see if they're any good or not. Here's a big filter cap up here. Probably be a good idea to short that guy out. Short these guys out. There's a bigger-ish one there. We're good. Okay. And zero out this guy. All right. So our big filter cap is right here. And it is good. Doesn't matter. What is it? It's 4,700 at 16 volts. How about you? You're good. You're good. Interesting. Okay. Kind of expect these little guys to be higher because, well, they're little guys, and that's just the way it works. Yeah, 1.6, 2.1, 3.5. That's a little bit higher than I like. 0.3. It's okay. I am actually quite surprised. 2.5. It's probably good. One of these blue guys down here, these guys usually go bad. Nope. Well, or it's got something across it creating 0. 1.7. 1.7. So none of these are actually looking horrible, but just to be on the safe side, they're all going away. 1.7. Make sure I'm reading correctly here. And these little guys down here, 0.38, 0.40. Well, they're not bad. However, we got to get these transistors out and see if they're starting to leak or not. So, guess that means I got to turn on the old soldering weapons, which I neglected to do. Sorry about that. Okay, where did it go? Oh, there it is. Turn on the solder sucker. And we'll let it warm up and be back in a minute. Alright, we're back. Solder weapon is hot. So, just for fun, let's take out this big cap and see if it tested. Actually, our tester was right. I am beginning to trust that in-circuit tester pretty well, but I still don't have absolute trust of the thing. Single-sided board should be pretty simple. It is marked. Okay, that's a weird mark. That's never seen that one before. It's marked with a little notch over there for negative. Huh, interesting. All the rest of them are too. All right. Let's get this guy down. Zero him out again. And yeah, that's fine. Just not making very good contact. There we go, 0.02. So that's just fine. 4700 at 16. So we're going to say that's good. So the rest of them probably are too. Let's pull out one of these transistors. 1, 2, 3, and a resistor. Okay, and it goes in that way. And it's been warm, look. Can you see that? It's been warm. Let's stick it in this little tester guy here. And see if it comes up. Alright, this is saying that it's an MPN with an HFE of 347. Holy smokes. 548 millivolts. Alright, well, let's test it on a meter. Because you're doing this along with me. I have not opened this thing up. I have no idea. We're just going to do it. So we're what? We're on ohms. Well, let's just measure it on ohms first. What is it? Is it marked? No, it's not. Probably. Let's see if I can figure out which way this thing is supposed to be here. Alright, so it's emitter collector base, I guess. Alright, so you can't see that because the meter won't show it, but let's turn the meter on here. So it's goes emitter collector base. So let's go base collector. We got 4.4 mega ohms. Base emitter 4.5 mega ohms. Base emitter collector. Emitter collector is open both ways. And base emitter is well, it's in the mega ohms. I don't have one to test against it, but that's don't think it's bad, to tell you the truth. And we're going to put it back in here because I believe I am going to replace it anyway, just so this thing can go back on the shelf and play nice and do its job for another 20 years. Interesting. Let's try this PNP version, I believe. And so this one would be this way. Okay, that's measuring 2 megs, 3 megs. And it bounced up and came back down again. Alright, so does it do it both ways? No, it goes up and drops back down. So I would say these guys are still good. However, like I said, I am going to replace them. I'm putting them back in so I don't lose them. So actually, doesn't look like this power supply has failed. It's just it's 0.3 volts off, basically. 2SB 1015. I don't know. I suppose we could check this one too. This one I don't have to take completely off. You can, whoops, go away. I mean, we know these transistors are all good, evidently. There's a 2SB, so that, I believe that's a PNP. Okay. No. 3.1 megs over. This is not the way to test transistors, by the way. 3 megs. This is just a quick to see if the thing is actually leaking. And it is not. So the 2SB 1015 is okay also. Alright, so it looks like all of the transistors and stuff on here is okay. Our resistors, 1.7K, 800 ohms. We're just looking for that 800 resistor value. 12K, 2.7, 12K. So all of these resistors, I expected them to be good. 47 ohms, because they're the kind of resistors that don't actually go bad. 15K. There's one you don't see a lot of. 5K. Yeah. This one's what, 20 something? 3.7. I mean, you can't tell, of course, doing this. Going up because of the cap. But 3.7, 5K. All right. Here's a diode. You won't be able to see this, but I can at least 0.65, 1.6 volts, but then, yeah, it's going across that transistor. All right, so it looks fine. We just have to see if we can scrape off some of this glue, this shipping glue. Stuff is just nasty, that shipping glue. Okay, there's its mark over there. And we'll test this. It said in circuit that it was fine. It probably is. But, this is the stuff you go through. 0.04. So, tell you what, just for fun, let's test it. Test these on the better than normal tester. Capacitors and 100 hertz. negative, positive. See what it says here. 920 microfarads, 86.99, and an ESR of 0.09 ohms. Well, that's good. And here's our 4700. This is the only machine I've got that'll actually read these accurately. Takes it a while to get there, so it's saying 3,900.041 and 84.07. So this cap is not all that great. Let's see if we can find one. Do I have a 4700 around here? I thought I had one out for some reason. Maybe not. Here's a 4700 at 10. That's at 16. Come on. Be nice. Play nice. So what does this say? .13, 84.94, and 34. So this one, it's not so much the whether it's leaking or not, it's the fact that it's out of tolerance. Well, that's interesting. I wonder if it does leak, because usually if you have these guys that are out of tolerance, they also will leak a little bit. So we will get Mr. Carlson's tester here. Now, this is going to take a while at 4700 for sure. Because it just does. So, where'd you go? Put this thing on electrolytics. And red to there, black to there. Alright, so I'll turn this on. And I'll bring you back after a while and see what it does. Okay, this took a long time. This is about, 12, 13 minutes on this thing. But if you can see it here, we're down to one last dot, which is still in the aha. All right, so this thing is not leaking, even by this guy's, but I'll bet you if I put this up to 16 volts, it's not going to last because it took forever. So we'll discharge it. And I pulled out the high voltage, voltage tester, and we'll see what it does on here. And that is discharged. Okay, so let's put it under load here. This is the black one, goes on negative. I mean, we're going through a lot of steps here that aren't necessary. We know that this thing is out of tolerance by 1,000 microfarads. All right. So there we are. Up on your, where is it? Right there. The top one is going to be the millivolts, or actually microvolts. So one volt is 1 millivolt, or milliamp. So, that's going to measure as low, the lowest it can measure that we're going to see is a microamp. So, we're down to 0. The bottom one is going to be output voltage. So when we turn this on, it's going to take quite a while to charge it. And it'll charge it up to 10 volts initially. And then we'll move it up a little bit. So we're up to 1.9. It's holding at about 4, but it's dropping as it goes up, so that's a good sign. And it's struggling to get up to 9, so let's crank it up a little bit. Let's take it off for right now, so we can take this up to about 16 volts, and then we'll hook it up. It'll take it a second. It'll take it a while to get there, actually. So we're back up to 450 microamps, but it is dropping. Okay, that's long enough. We're up to 15.26. We're down to 55 microamps, and that's more than good enough for this capacitor. I mean, it's better than the book shows, I'm sure. Let's discharge this guy. It discharges a lot faster than it charges. And just for fun, we'll hook up this 1000, which won't take near as long. This one's 25 volts. This is a handy little device, too, if you want. Oh, you see, I put my stencils on it. Yeah, and I'm going to cover up this one here. But, yeah, I put stencils on it, so it looks a lot better than it did before. Little press supplies. Thank you, guys, for telling me what those were called. Dry transfer. Yeah, they work pretty good. They're a lot more finicky than I remember them being in the old days. All right, 2 volts, that's good enough. All right, and let's give this guy a try. This is 1000 at 25. So let's turn it up to 25 volts. I got a suggestion on this to put a switch in here with diode or with resistors on it, so that I could go just 100, 200, 300, 400, 500 volts, and that'd be great. But then I'd also have to have a position on the switch that was another pot for adjustable over here, because I do like being able to use this down in the 25 volt range. I'm still thinking about that, Crank it down. Thank you for your suggestion. 2555. All right. So here we go. We'll hook this guy up. Hook it up right. And see what it does. All right. So this is going to climb quite a bit faster. We're at 1 milliamp at this point, down to 900 microamps. And climbing, but that the microamps is dropping even as the voltage goes up. Still looking for a nice little analog meter on this that goes to 600 volts. That's not that easy to find, let me tell you. So we're 20 volts down to 300 microamps. Goes a lot faster when it's a smaller cap, I'll tell you. $22, $23. What you want to do is you want to get this up to its voltage, and then see how far down your current goes. 24, and climbing. And getting real close here. I don't know what the what is this? I don't know. SM. I'm not sure what that symbol is on there. Maybe somebody can tell me. I mean, we could look these up on a data sheet, but I can flat guarantee you that what we're getting on them is as far as current leakage is fine. Because even the best ones. Oh, we're down to 15 microamps, and we're at our voltage, and we're still dropping. So, 12 microamps, 11. Okay, so it looks like we've hit our minimum here on this capacitor. And what we've got, it's varying a little bit. I switched it over into millivolts, so we've got about 2.6 microamps at its full rated 25 volts. That's a good cap, period. So, let's discharge this guy. As we drop down in the microamps, that makes no sense at all because it's backwards in there. Anyway, so these caps out of this thing are good. And I can guarantee you they are. But we're going to do the service on it anyway. Because that's what he requested, and that's what I'm going to do. Anyway, so I'll get back to you when I have the parts to put in here. I wonder how hard this junk is to get off of here. Not bad. It hasn't turned into concrete quite yet. So I'll be able to get that off of there pretty good. Easily. Pretty good. I speak English good. Wow. It sticks better in some places than others. It's still stuff's a pain in the ass. I know why they do it. They put this stuff on here so the caps don't rock around in shipping, but really, make something that doesn't get, well, they don't do it anymore. There, that one's gone. Hitting that diode. That's a diode for the 78 and 79 15s. It's one of the better ways of doing it. So, all right. So I'll get the transistors for this, and I'll order in the caps for it, and we'll put it back together and see if it makes any difference on when we get it back in for as far as the voltage goes. Okay, so we're back. I got all the parts in, changed all the capacitors over here, replaced both of these transistors and this transistor back here. This one is a 1051 or something like that, 1015. It didn't actually look even a little bit bad, but I figured it's a 60-cent transistor, may as well go for it. I did check all the capacitors I took out. There were a couple of the smaller ones that had a 10, ESR of 10, which isn't horrible, but it's bad. I'm going to say it's bad. And there were a little more disturbing that had an ESR of 0. Now, if you're using an ESR meter and you get a reading of 0, it could mean a couple of things. It means either that is a really good cap, or it's completely open or completely shorted. There's something wrong with it. So I had to check it on other meters, and those ones with 0 evidently were just really good caps, because you've seen all the stuff I got to check capacitors with. The capacitance was right. Their phase relationship was right. They didn't break down at the voltage that they said that they were. As far as passing current, everything was fine on them, but I replaced them anyway. Let's face it, it's a couple of bucks in half an hour. You just do it anyway. So I've had this thing on for a good 45 minutes or an hour now. I don't know. I got involved watching some videos of flat earthers, and I was laughing so hard I couldn't actually make a video for quite a while there. Anyway, so I've had this on for a while, and we want to check and see where our voltages are now. You remember correctly, we were up at plus and minus 15.3, 15.4, somewhere around there, and 5 was 0.1. To me, that's fine. But one of the complaints about these guys is the transistors start to leak. This thing is old, and we'll just go for it and change them. So let's take a look and see what we got for voltages here now. This one is the 5 volts, I believe. Yes. And we got 5.25 volts. That comes off of one of these transistors. So 5.25 on the 5 volts scale. That's good enough. That's 0.2 of a volt. Think about that for a minute. Something like this age, 0.2 of a volt is not really going to hurt anything. This stuff's not even going to notice. Next one over, minus 5.13, or 5.16. That's fine. Our next one over here, and this one we also want to look at our ripple down here, which we don't really have any, is 15.19. So that's down a little bit as far as voltage goes. I did not replace the plus and minus 15 volt regulators here, because they are doing their job. And this one is minus 15.3, so there wasn't any change in that. So, but we do not have any ripple. It's fine. It looks just fine. Matter of fact, let's take the meter. Let's put it on AC and take a look at them. Here are 5 volts. We have a 0.23 volts of AC on there. Here's our negative 5 volts. We got 0.21 volts of of AC. Here's our 15 volts, 0.214, and our other 15 volts, 0.217. So yeah, we've got what this probe is picking up, okay, out of the air. Me touching it gives it more than that. So yeah, we're fine. All of the voltages are good. Everything is fine. It's run for a while. It's going to go on to the burn-in bench as soon as I remove another piece that I got here. And we're going to run this for 24 hours straight and make sure that everything's fine. I did go through and check all of these little capacitors. These are bypass capacitors on all the chips. Some of them are bypass, some of them are actually feeds. But all of them were good. All of them had 4, 5, 3 around ESR values, and all of them were just fine. So, anyway, put this on the bench, let it burn in for 24 hours, and if it is, we we send it back to the guy and say, hey, it's ready for another 25 or 30 years of service. Thanks for dropping by, guys, and don't forget to subscribe and ring that little bell down there in the bottom. And don't forget, I've got a Patreon page if you feel like supporting me. So, till next time.